We continue with Section 7A, Fundamentals of Probability. And in this video, we will do problems 7 through 11 in the worksheet. Solving problems where we just use the basic idea of probability and the basic counting techniques if necessary. So we're going to select a pair of socks from a drawer that contains 5 black, 9 blue, and 8 white pairs. We're assuming all the pairs are, each pair is together. So there are a total of 22 pairs. So that's our total number of pairs of socks. Our next step is to figure out how many white pairs are in 22 pairs, because we need to find the probability of selecting a white pair of socks. So we have, out of the 22, 8 are white. And the third step is to actually calculate the probability. Probability is always something over something. It's a fraction. The denominator always has the total number in problems like these. And what favors the event that we're interested in is always in the numerator. So 8 divided by 22, which is 4 over 11, is the probability of selecting a white pair. The next problem is giving us some information. It says a survey shows that 150 out of the 760 adults in the city have diabetes. What is the probability that a randomly chosen adult in the city does not have diabetes? So 150 out of 760 have diabetes. The probability that a person has diabetes is 150 out of 760. We need to figure out the probability that someone does not have diabetes. So it's the probability of no diabetes, which is the opposite of diabetes. Now, if you remember, there was a rule that we did. What is the probability of an event not happening? The probability of not A is equal to 1 minus probability of A. So when we're given a certain probability and we're being asked to find the probability of that event not happening, then you have to remind yourself that this is the rule that we need to use. So probability of no diabetes is equal to 1 minus the probability of diabetes. So I'm just translating the rule to this particular context. So we have 1 minus the probability of diabetes is 150 over 760. When we simplify it, we get 610 over 760, which is equal to 61 over 76. And that's also approximately equal to 0.8026. So the probability that someone does not have diabetes is 61 out of 71. 61 out of 76, or approximately equal to 80%, 0.80. You could use your calculator to reduce fractions. There are different ways of doing that depending on your calculator. If you're given 2 out of 4, there is a function in your calculator that would reduce it to 1 over 2. Let me know if you need help with your particular calculator to figure out this function. The next problem let's look at 9. What is the probability that the next person you meet was not born in July? So what is the probability that a person is not born in July? So the minute you see the word not, that is sometimes a hint. So what is the probability that the person is born in July? July has 31 days. Assume a total of 365 days in a year. So the probability is a ratio. It's 31 over 365. that is the probability that someone is born in July. What is the probability of the opposite event? So we have 1 minus probability of the person being born in July is equal to the probability that the person is not born in July. So it is the same rule again. So 1 minus 31 over 365 simplifies to 334 over 365. That's the probability that the person is not born in July. Another important term in probability that we need to understand is probability distribution. So for every experiment, every probabilistic experiment, we can write down the probability distribution. Now, what exactly is a probability distribution? Every experiment has a list of outcomes. So suppose we list outcomes in the first column and the probability of each outcome in the second column. So for every outcome, you have the outcome and you have the probability, the outcome, the probability, the outcome, the probability. So the list of all outcomes along with the corresponding probabilities is called a probability distribution. So the first column must have all possible outcomes. It is not a legitimate distribution if all the outcomes are not listed. Now, in the second column, make sure that you have the exact, or sometimes it's not possible, you might have to do some rounding, the probabilities as close as possible to the exact of every single outcome. Now, if the probabilities are listed correctly, they all add up to 1. The sum of all probabilities add up to 1. So if you need to check if a given table is a probability distribution, there are 3 things to check. 1, are all the possibilities or outcomes listed? 2, is every corresponding probability written in the second column? 3, do all the probabilities add up to 1? So these are the 3 things to check for a probability distribution. So in question 10, let's see if we can construct the probability distribution. So let's see what the experiment is first. The experiment is tossing or rolling 2 fair 4-sided dice. A 4-sided dice instead of a 6-sided one would have only 4 possibilities. 1, 2, 3, 4. So if we had to list all the possibilities when we toss 2 dice, each is 4-sided, so the first blank can be filled in 4 different ways, the second blank can be filled in 4 different ways. The total number of possibilities is 4 times 4 equals 16. So if we have to list all the outcomes, we can be sure there are 16 possible outcomes. So what does an outcome look like? So we roll the die. First one rolls a 1, the second one a 1. So 1, 1 is an outcome. First roll is a 1, the second dice rolled is 2. First 1, next 3. First 1, next 4. And you can see the pattern. And we can exhaust all the possibilities by writing it in order. There'll be a total of 16 possibilities in the set of all possible outcomes. Now, what we're interested in is not the actual outcomes, what comes first, what comes next, but we want to find the sum of all the outcomes. So if we think about what the sum of the outcomes might look like, for example, if we look at 1, 1, the sum is 1 plus 1, 2. And if we look at, for example, 3, 4 or 4, 3, although they are 2 different outcomes, the sum is 7. So 4, 4, the sum is equal to 4 plus 4 equals 8. The smallest sum is 2, as you can see, and the largest sum is 8. It is not possible to get anything a sum that is larger than 8. So if we are looking at the sums in this particular experiment of tossing two fair four-sided die, then the lowest number that we can get is a 2, and the highest number that we can get is an 8. Now let's make a probability distribution. What does our probability distribution look like? So we have a table. We have outcomes in the first column, and we have the corresponding probabilities in the second column. So what are the possible outcomes? The sums is what we're interested in. The lowest sum can only be a 2. We can also have a 3, 4, 5, 6, 7, and the highest sum of the two numbers can only be an 8. So let's see what the probability of each of these outcomes is. So the outcomes are 2, 3, 4, 5, 6, 7, and 8. That covers all the outcomes. Now let's look at the corresponding probabilities. There are a total of 16 outcomes. How do we get a 2, a sum of 2? The only way we can get a sum of 2 is to have 1 in the first roll and the second die rolled is also a 1. That's the only way we can get a 2 as a sum. So there's only one outcome that gives us a sum of 2. 1 out of the 16 outcomes gives us a sum. So 1 out of 16 is the probability of getting 2 as the sum. What's the probability of getting 3 as the sum? There are two ways in which we can get 3 as a sum. So it could be 1, 2 or 2, 1. Each pair adds up to 3. So there are 2 out of 16 outcomes that give us 3. So the probability of getting a 3 is 2 out of 16. Similarly, we can go through the list. Let's look at 5. What are the different ways in which we can get 5 as the sum? It could be 1, 4, 4, 1, 3, 2, 2, 3. These are the only ways in which we can get a sum of 5. So there are 4 different outcomes that will give us a sum of 5 out of the 16 different outcomes. So 4 out of 16 is the probability of getting a 5 as a sum. And finally, let's just look at 8. What are the different ways in which we can get 8? We roll a 4 first and then a 4 on the next. So 4 plus 4 equals 8. So there's only one way in which we can get a total of 8. So that's 1 out of 16 outcomes, which is our probability. So if we add all these numbers, 1 plus 2 plus 3 plus 4 plus 3 plus 2 plus 1, it comes up to 16. So when we add all these fractions in the second column, we get 16 over 16, which is equal to 1. So this is a complete legitimate probability distribution. What are the 3 things to check? Are all outcomes listed? Check. Have we carefully calculated the probability of each outcome? Check. Add up all the probabilities. Do we get equal to 1? Check. We've completed the probability distribution. What are the odds for an event? What are the odds against an event? We hear this terminology in usually betting games. What are the odds for winning a certain game, or what are the odds against winning a certain game? So this is the way in which we calculate the odds for or against a certain event. What are the odds for a certain event A? It's the probability of A, so the favorable probability of that event, and what's the probability of that event not happening? That ratio, or that fraction, where the probability of that event happening is in the numerator, then that would be the probability for that event A. What are the odds against an event A? So the odds against an event A is again a ratio. In the numerator, we have probability of that event not happening, since it's the odds against an event A. And in the denominator, we have the opposite, which is the probability of that event actually happening. So let's look at problem 11. What are the odds for and against the particular event that we're interested in? So what is the event of interest here? We have flipping two fair coins and getting a head and a tail. That is the event that we're interested in. What is the probability of getting one head and one tail if we flip two coins? So one head and one tail doesn't specify the order in which the head and tail appear. So we'd have to consider both the orders. So HT and TH would both come under getting a head and a tail. So the probability of getting a head and tail is 2 out of the total of 4. What are all the possibilities is HT, TH, HH, and TT. So out of those 4, 2 favor the event of getting one head, one tail. What is the probability of the opposite happening, not getting one head, one tail? If you're not getting one head, one tail, then we're getting two tails or two heads. That's one way of calculating it. But since we already have the probability of getting one head and one tail, we subtract that from 1 using the rule of complements. Then we have 1 minus half equals half. So now we calculate the odds for the event of getting one head, one tail. So the probability of getting one head, one tail, so that is the favorable event, divided by the probability of the opposite not getting one head and one tail. So using the formula for odds for the event, it's half over half, which is equal to 1 over 1. Nothing's going to change if we reverse this or if we take the reciprocal of that particular fraction. So odds against the event would be probability of not getting one head, one tail, divided by probability of getting one head, one tail. So 1 over 1, half over half is 1 over 1. So in this case, both were equal to 1 over 1. Let's consider an example of where we're interested in the event of getting two tails. So that's TT. Probability of getting two tails is 1/4. Probability of not getting two tails is 1 minus the opposite, that is getting two tails, and that's equal to 3/4. What are the odds for the event TT? Odds for the event is probability of the favorable event, that is getting TT, over probability of not getting TT. So divide one by the other. Probability of getting TT is 1/4. Not getting two tails is 3/4. One divided by the other is 1/3. So the odds for the event of getting two tails is 1 to 3. It's 1 over 3, which is the same as 1 to 3. What are the odds against the event TT? So we use the formula. What is the probability of the event not happening, not getting two tails, over probability of the favorable event, which is getting two tails? Since we look at the odds against, we put the not in the numerator. So we have 3/4 divided by 1/4, which is 3. That is 3 over 1. So the odds against getting two tails is 3 to 1.